Hey guys, this is Mainak. So this will be a full course on how to design a building in STAAD and RCDC. So we're going to go by equivalent static method in this particular video, and process of RCDC stays same for the equivalent static method and also the response vector method. But I will also do the response vector method in another video just to show you. So first of all, you have a file here, and the first thing which you need to do is you need to make the center line and get the centerline coordinates in this software, and after that we can copy to Excel or can directly just do it. So first of all, we'll draw the centerline here after the architectural part is completed. Okay, so for the preference purpose we'll only go for the main beams here. Okay, for now. Okay, you can just take the center and okay, and then we can make them uniform data. Just take this, take from this center, denoting the triangle denotes the center here, this center, this center, this center, and this center, and we will denote this point also. Okay, and later all the secondary beams will ignore. So let's start. So if you just see the coordinate of the STAAD also, let's open the STAAD. Okay, and then we'll see. So STAAD has been opened. Click on new, and I'll just browse to the location in which I want this. Just name this STAAD file. Okay, here units will be metric here, and we'll go here, create, and just go to the top view here, and you can see this is the z-axis, z, and this is the x. So x and z are like this here. So x is positive in right side and z is positive in the top direction. So like this will make the coordinates. Okay, so first coordinate we'll just write in the text here. Using multi-line text, we'll write it here. First we'll write all this one into 0, 0. Okay, and the unit will take in meters, right? So unit will be meters, 0, 0. I think I can increase the size of this. Go T200 for this. Can even change the color just to denote this. Just give the right color since I'll copy this one. So then we need the coordinate of this. So this will be z will be 0, x will be have a value here. So x will have 4.25. You can notice this as well, which one is first, which one is second in STAAD.Pro. We will say x is first, and after that it is z. So it will be 4.25, 0, and same thing. You can just extend this. No need to take another one. So you can just copy this. This will be 8.15, 0. Like this it is there. And for the next coordinate we need another dimension line here. So I'll just copy this. Since the x coordinate will be the same, only the z coordinate will change here. Okay, so here only for one we write 5.35. Since it is downwards, it will be the negative direction, so it is minus 5.35. And just copy this, and we'll paste it here and replace. Okay, then we'll just copy this once again and do it here also. This is 8.475. Okay, same, let's go for the next layer. So 13.271. I'll take this coordinate as well. I'll give a beam here. Okay, so these coordinates are done here, so it's pretty much simple here. And then you can just do it in STAAD.Pro, or you can do it in Excel also. So I just prefer Excel because it if you want to paste code and paste again in the next code also, it is easier. So you can use or use not use Excel, it's up to you. I use WPS Office, which is similar any spreadsheet program. Basically you can use, no problem in that. Okay, so I just type here X and then Y and then Z. So we'll take this plinth level as 0, so Y will be 0 here, and X and Z will just write here. I'll just zoom in for you to, and this will be the number, and zoom in for you to just to see it better. Okay, so first coordinate is 0 0 0 0 0 0. I'll just do it at the center. That again, yeah. Second coordinate is will be 4.25 comma 0 25 0. Next coordinate will be sorry, I keep pressing this 8.15 0, and this is 0 anyway. So these three things will be the same. Okay, yes, and again this coordinate will change. For the next one, it is minus 5.35. And for the next one, it is minus 8.475. Okay, and the next layer also we have minus 8.475. This will be copied and pasted in these two, and this one will be copied once again, and this one we have minus 13.271, minus 13.271, and this can be copied in these two. Now same, we copy this here. I think there is an extra thing in here which I have not marked. Okay, there is extra column here just to be marked. So this one, right? It is 5.325. I think no point giving this. If you want to give beam, then it's okay, otherwise there is no point giving this thing here, and just go stick with 5.325 here. Okay, for now. copy, paste, and this one will be 13.271. Not 13, sorry, it will be more, 15.496. I have not done that. Correct. This one is not required. $15.496. Okay, so this is seems done. One, just drag this and copy, and then every point has a column, so there is no problem in that. Paste it. Okay, so we'll go to geometry, add beam, and we'll select left click. We want to give a beam here, we should add a point. Yeah, that I should add. Okay, let me just add that point. If I want to give a beam here, we might need to give a beam here, because otherwise this particular slab would be too large when you go upwards. So it's better if we give a beam here. So it will be 5.325 comma 13.271. Okay, 16. And just copy this, open STAAD, select this, okay, just select all the nodes here. Go to select node cursor, select all the nodes, and go to view, and then isometric view, and then we'll use the translation repeat from going to geometry, translation repeat, y direction, and we'll do 1.5 the foundation depth, and 0.45 will be plinth height, so minus 1.95, and this will be in the y direction obviously, and we'll do link steps and then click on OK. So this is the base here. So for the base, you can do this later. So we can go view and select the front view. This is, make sure you have the beam cursor on, select this portion, and then we'll use translation repeat again, geometry, and then we'll use, okay, I think we have one place where we don't have any column, so I have to delete that. Yeah, sorry. Yeah, that, like this particular thing, this, if you go over the top view first, this particular node doesn't have any column, so you have to delete this. This one. Okay, so now it's okay. So we cannot use link steps, since there is one point which doesn't have any column, so we cannot use link steps here. Okay, no problem. I'll just go to front view and select this, and then we'll go to geometry, and then we'll use translation repeat, y direction, no link step used. We just have 3 meters, and then we have one step only for now. and then after you do this, you can use link step later. Okay, so let's go to this isometric view, and then geometry, and then add beam. Yes, just add the beams properly. You can easily identify the places where bottom we have columns, and place wrongly, then this option will come. So like this, you can know that you have selected wrong point. So to ensure that all the bottom places are columns, we have to go to select parallel to Y. So this everything is selected, means it's okay. Then we'll go to view, then we'll go to front view, and then select this like this to include this. So then this will be a foundation for a G+2 building. So we'll have add two more stories here. So we'll go geometry and translation repeat, Y direction 3 meters, 2 steps, no link steps because we will exit everything. Click on OK, done, and then go to properties. Okay, then we'll define the properties here for the columns. First of all, for the columns, define 350 to 350.35 0.35 and click on add. And for the plane beam, we'll define as 250 to 350 add, and for the roof beam, we'll define 350 plus 125 475, or let's go 415 or 425. Let's 300 will be the beam and 125 will be in the slabs, like that we're thinking. 425 will go. Let's click on add and let's close this. So go to view, full isometric view, this, select this and select parallel to Y. Sign, this is for the plane beam, right? So view and go to front, select this and assign, and yes. The next one, select this and select this and also select this, assign, and yes. So then you go to material, but by default concrete is selected, so no problem in that. You can edit the material as well, concrete. So you can see the composite strength. If you want to change it, you can change it. If you want to do M25, M30, you can do 30. Let's do M30 here. The G+2 building, M30 is preferred. Or let's do M25, 25, 1, 2, 3, 25,000, and click on OK. Okay, and then specifications here. For the specifications, you can see, you can just denote some things in the specification, like rack sections. You can define for the specification. Okay, and also in the specification you can just give the things for the primary and the secondary beams as well. Okay, and if you want to include the offset also, you can do. So but specifically compulsorily, if you are for zone 4 or zone 5, and the factor which you need to add is the reduction factor for moment of inertia, okay, along Y and Z for the beams and for the columns. So the clause is for the beams we take 35%, and for the columns we take 70% of the cross section area. Let me show you the code. So you can see the code here, IS 893 part 1 2016 for structural analysis, RC and masonry structures, 70% of across of columns and 35% for beams. So just go here and we'll go with this point 0.35 and 0.25 and click on add. Okay, and beam only. Now everything is beam, so property reduction factors include 70% for the column 7, 0.7 and 0.7 like this. Click on add, and now for the first one, go to view, go to front view, and go to select parallel to X, parallel to Z, and assign, and then select this parallel to Y, assign yes. Okay, so everything in here has a purpose. We are achieving that particular purpose in here. Okay, I think you missed something due to my camera location. I'm sorry, apologize for that. Just done this specification, two specifications I have done here, and just show you in edit. So basically I just gone to beam, and then I've gone to this property reduction factors, and for the beam I had taken as 35% for these three, and for the columns I had taken as 70%, because as per the code. So code one part you saw 70%, 35%. This process you might just miss something. So just turn off my camera to just take the whole view of the screen. Then we just selected the columns and things, and we just assigned. So everything has a purpose in this STAAD here. So the next thing which we want to do, because only one beam is like that, which doesn't have the column to column connection. So I'm just going to zoom in on that for you to have a better understanding. So this also has to be solved in here, that's why. So right click and click on we'll just go to click on new view and click on OK, and then we'll just select this, and we'll right click, and then we'll go to we have a view options or display options, and you can see this this is here. I think we can go to view and just set some options here just to view this. Just give me a moment. Okay, so it is right click and then go to labels, right, and then beam and colors, click on apply and click on OK. So you'll find the beam starting and end color. Start color is green and end color is blue. So in here the blue or the end doesn't have a fixed connection. Only here we have a column here, and in this place, in this blue location, we don't have a column. So this will be a pin connection. So if you want to create a pin connection here, moment release, start and end. So a moment at release at end you want to do, and releases you want to release the moments here. And 3 direction full release of moment you want to do, and you want to click on add. Okay, so moment release and MX, MY, MZ. So you want to select all these 3 parts you want to select, and you want to add this. So you can easily do this in the, I think best option to go at a time is you can go to the isometric view of this and select, and go to the display whole structure, and just go to the top view and select this beam like this. Okay, and just check whether all these beams are selected or not. You can see all these beams are selected like this, and assign and yes. So this property has been assigned here clearly like this. So since this property has been assigned, so we have done the purpose of specification. Then we go to supports. Okay, then we create the support here. First of all, since we are using static method, equivalent static method, so join to it method will not be required. So we create only one support, fixed support for the base, and the best easiest way as per my view to just select this and then assign and yes, and you can check in the 3D view as well whether everything is assigned or not. So the purpose of support is gone now. So the next purpose is to loading. So loading here, so in this, since we are designing this building in zone 5, so definitions are seismic definitions obviously required. The places where you have these other factors, mainly wind factor, which you need you have to define that as well, since we are going by the equivalent static, so you don't need pushover or time history analysis here. So just click on add here, and we'll just add the seismic parameters here. Just select your code here, we'll go with 2016 and click on generate. And there is a easy method as well, which you can just surpass all these steps. I'll just show the easy method. I'll also give you a file by which you can make your loading parts super fast, and you have to do literally nothing. Just from the code you have to see some values and put. So I'll just give you that as well, but in this video I'm just showing you the general process. Okay, so we'll go, our building is in zone 5, so I'll select zone 5 and we'll select the RC moment resisting frame, special moment resisting frame, and this doesn't have occupancy here, so we'll go with 1, and medium soil will go here, and damping ratio foundation depth is 1.5 meters, and then period in x and y direction. I always tell you to calculate this and put, don't go with 0.5. If you go with 0.5, the results will be in the little bit less conservative side. So I show you this in almost every video. So the clause is 6.4.2 in here. So you can go for this factor here in the x and the y direction for zone 5. This will be zone 5. Z is z is point z by 2 is z by 2 directly. Let me write z by 2 is equals to 0.18. okay, 0.18, and AH is equals to, and the building height. Okay, building height we have to take in SA by G. SA by G you can take and generally I is 1 here, R is 5 obviously, and here, so this is not required now, so this is the this case will be required. I'm just done it. This is the TA. So for x and y, the building height can be taken as 9 3 stores plus plinth height 0.45, so 9.45 meters. You can also see in the elevation here. Okay, 9.45 meter. You can see plinth height is like this, down below ground level is from this. So okay, so 9.45 meter is the plinth height, and then you will have the in x direction. So the other thing is required in x direction and y direction. The x direction it is 8.14. Let's take 8.2, and in y direction, or here in STAAD.Pro Z direction, it is 15.496. This can take as 16, right? Okay, so 15.496 we can take as 16. So let's take this as 16, and I'll just calculate this into 9.45 divided by root 16.212. Take 0.21, so it will be 0.29 and 0.21 in x and z. X will be 0.29, z it will be 0.21, and then click on generate. Okay, click on add. Remaining thing we can add later in the STAAD editor file. So load cases, let's add. First of all, primary, I'll add this seismic load. So SL X, SL Y. So take down the caps better. So as per the IS code, in seismic zone 3 and 5 you have to add seismic load in all the 3 directions, so that's why I'm adding this. So then that load you can add, and then the live load also you can add. Okay, and then edit this. It looks kind of odd, only that's okay, change. Okay, so now you can add this contents here. SLX add, we'll go here, seismic loads in the x direction factor of 1, add this and close. seismic load in the y direction, factor of 1 on it. Z direction, sorry, just messed up. Didn't select seismic load. Okay, so seismic loads in y direction, factor of 1, and this will be seismic load in z direction, factor of 1. Close this. Then dead load, let's put some simple dead loads here. First, the compulsory self weight you obviously have to provide, and then the next is the floor finish load plus the floor finish load. Let's go here, floor finish load in the floor load area, and then the floor load area, floor finish load will be 0.5. Let's just calculate this and put it once. Okay, let's finish floor finish load will give here, which is 0.5. So minus 0.5 the floor finish load, and the range we'll just put here. Let's start from minimum 2.9. Since the bottom floor there will not be any slab, so with the field level there will not be any slab, so 2.9 to maximum there is 3 floor, which means that is 9, so 9.1. Let's test it. Okay, let's test it first. Now this is okay. So I think with this view we don't need again. So levels, let's just end this now. Okay, so this is okay, and we just will add this one, this self weight. This one we can assign to view, assign and yes. The remaining loads, remaining 2 loads we'll add in the STAAD editor or command file. Sorry, now in the connect version it is called command file. So we'll just zoom in, and here, okay, this will go to the dead load part where you'll just assign the floor load, and then next floor load we'll just do, I'll copy this, and next floor load we'll assign, and this time we'll just give a floor load of the slab. So if you are calculating the 125 mm slabs, just let's take 150 to be more precise. 0.15 into 25 means 3.75. 3.75 is the weight of the slab. So this weight of the slab, so we can just add here 3.75. And in the editor file you can just add here, like this is the floor finish load, and don't worry, you just select this and comment, it will stay as comment, and like this you can copy this, and then next after that we can just add this one also, just so that you only know, or anyone who checks the file, this is the slab weight. Okay, slab weight. So slab weight has been taken this for this, and for the live load the range will be the same. Okay, and the live load range will be the same only for the residential building. The live load, it will be 2 for residential, since it's acting downwards, so it is -2. And the remaining load we have to apply manually. Let's just check. You can always check syntax and then save this when you don't have any error, and after saving this you can close. So still using some tricks in the STAAD editor, not using the full STAAD editor version. We'll show you another version which is a lot more easy, but this minimum tricks you should use. Okay, so live load and dead load, we are live load is done. Dead load we need to add more. Okay, dead load we need to add. We have to add the weight of the wall. So the wall is of 3 meter. Let's take full. Let's take at least some portion of slab will be there. Let's take 3 meter into 0.20 weight of the plaster into 0.125 the weight of the wall. This is 3 into 0.125 into 20 kN per meter square. 7.5 is the load which will apply. So dead load, add, and weight of the wall member load minus 7.5. So it is pretty easy to apply here in STAAD. And let's add another member load for the parapet wall as well. Okay, so member load of -3 for the parapet wall. -3 is too much. Okay, let it be. Okay, so view and select, and then select this, select this, select this, assign. Okay, 3.51 I will apply it. Let's go select this and right click, and then new view. Okay, then just select all the portions except the portion where you potentially have the staircase. You can just ignore that part. Okay, and then again the remaining part you can just assign to select beams, assign, and yes. Okay, so now dead load and live load is defined. So seismic load, seismic weight will automatically be defined in the STAAD editor. Seismic, what is seismic weight? Full dead load plus a percentage of the live load. So what will percentage of live load? It will be 25% since the live load is less than 2. If it is more than 3, then it will be 50%. Okay, as simple as that, the definition. So let's go and save the file once, and we'll go to the command file. So you have to start to just call this command file. Earlier, because it was STAAD editor, I still call STAAD editor. So yeah, command file. So full dead load without looking, you can just copy. You don't need to just even think also. Full dead load you copy. In the live load you have to think, right? So you can see what the definitions you have defined here like this, and then we just paste it. And then we have to fix some things. Okay, just like this sign and direction will just change, and then this will be the weight, not in place of the load. Okay, so in place of load, just fix this weight and this also, and just do one by one. Okay, just change this first member weight. Okay, now what we'll do, now we'll get rid of the direction and sign. Direction, get rid of direction, get rid of sign. Okay, get rid of direction, get rid of sign, get rid of direction, get rid of sign, get rid of sign, get rid of direction. Okay, so this is done. As simple as that. Now another thing we have to copy. This is the live load. Live load, let's just copy, simply copy it, live load, and let's see where it ends. Here, this one, it ends here. Enter and paste. And obviously weight, you have to just change this to weight, copy and paste. So what is 25% of 0.2? 0.5. So this, as simple as that. Just check syntax, and once just give some time to check syntax. Don't hurry, don't panic. Press Ctrl+S to save this, and then just you can just go out. So like that, in a moment your loading part has been completed. Here like this, you can see loading part has been completed. So let's go load combination also. You can go load combinations also for this. Okay, so load combinations you can go by the by default load combination, or if you want the codal load combination style, I'll just give you a trick for the codal load combinations also. Okay, so I'll give you the link of this particular file for free in the description, and you can just copy this like this. Okay, but all these load combination are as per IS code. You don't need to define them and again one by one. No need to do that. So you can easily just do this easily. So just copy this. All these are as per the code. Okay, these load combinations, every load combination you have. If you just STAAD by STAAD, sometimes you don't get those things. So that's why I'm just showing you. Just you have to right click and copy. Okay, copy all these things, and then you can paste it to the STAAD command file. So I opened the STAAD command file. Let's just telling you once again, this thing will also only work if you are using the load combinations in the same sequence as I have done. Okay, so you have to follow them properly. So yes, done. Check the syntax, and okay, just check for this. and then close this. And then after all this is done, you can see this load combination, and two load envelopes are also defined. These envelopes will help you in the post-processing mode to just see some many things, and also the live load and dead load, these are already done, but you can also see these load combinations are there. And once this load combinations are there, you can simply go to analysis here and just add the analysis commands. Analysis command will add all, and click on add, and then close this thing for now, and then design concrete as 456, and then we'll go to select parameters, select the minimum parameters required. What are the minimum parameters? FC you need to define, compressive strength of concrete, and FY main and FY secondary you need to define, and other things you don't need to define, just define parameters. FC will go M25, so 25 1 2 3, and then click on add. FY main will go 500 1 2 3, click on add. FY secondary will go 500 1 2 3, click on add and close, and then commands, and then we'll go design beam and then design column. We don't need takeoff for now, just close this. Slab we're not doing, so FC all will be assigned to view here, everything except design beam and design column. Okay, since design beam will be, select all the beams here, parallel to X, parallel to Z, and then we'll assign, and yes. Design columns parallel to Y, and then assign, and yes. And then we go here, analysis and design, run analysis. Let's see if we have any errors in our program or not. So if you have any error, the error most probably the things will end at the start, so don't have any errors here. Okay, and warnings are also not less, means the concrete design is done. You can see the concrete design, just keep this sample ones here. You can see 8 bars of 16 mm here for the beam. Let's take the beam here. Concrete design for the beam 612 510 looks good. This also looks good, since we've applied all the load combinations and applied all the factors here. So you can see easily how this is done. So I think I'll keep the RCDC part to another video. This is enough since it is too long. So the RCDC part I'll do in the next upcoming video, but you can see the entire design things have been done, and you can easily, I'll just show you the use of the envelopes which I've just created here. So you can go to the post-processing mode, post-processing from here, and you can select the load and envelope. So one is strength and serviceability. So let's select envelope 1 for example, click on apply and OK, and then you can see all the results here from the post-processing mode here. In just control and plus this, okay, MY and FZ, okay. This displacement, just untick displacement here, untick MY. So this is the MY. So this is the bending moments. You can see increase the magnitude by pressing control and then this MY, and MZ is this bending moment here. MX will not find anything, so it is MY, just MZ here. Okay, in the Z direction you can see the increase the magnitude, control and then mouse wheel. This is perfect, and then you can see this thing, and you can in fact annotate also, annotate beam results, bending ends, and okay, just let's select ends and maximum, or ends, midpoint, maximum, both. Shear and midpoint, maximum, you can annotate, and yeah, you can see this. So this is a lot, so I'll just click on maximum here and click on annotate here, so you'll see only the maximum points here, you can see. So like this, you can just MY also, you can see the maximum points. And for the shear force as well, shear force, you can see the shear force diagram properly in the FY. You can also go to annotate here and see the beam results. Annotate shear, let's go maximum 1, okay, or ends only, and then click on annotate. You can see the thing at ends here, okay, in kilonewton. You will see the values here at the ends. So you can select a particular beam to you to see it properly also. Let me just show you. Let me select let me suppose this and this, and then right click, and then, or let's click at like greater one, this and this, and right click, and then new view, and click on OK. So that will have a, you'll have a better view of this, since we'll have all the things here annotate. Okay, maximum annotate, you can see maximum here, and this is really beam stresses also, you can see here the beam stresses, and just increase the beam stresses here like this. Deflection, you can see the deflection here, and then the displacement also, you can see. Utilization ratio is in green, so it is not much. Okay, so here you can easily see those things here, and animations and everything in the post processing mode. You can just see all the things here. So loading diagram also, you can just see the loading diagram for this particular. So this envelope makes them easy, and if you I'm just going back to our envelopes which you have created, and going back to the loading part, and there are two envelopes, it is serviceability and strength. So you can see if you go in the serviceability envelope is envelope 1, and 2 is strength envelope. So I'm just going to utilities and the command file once again, just to show you a little bit. So just see, so serviceability load combination, you can see everything is 1 1 1 1 1, 0.8 and 0.8 of two directions, and then 30% of the other two directions are 3 directions. So you can see, and the strength load combination, you see the load combinations are higher, 1.2 1.2 4.6. all these are given in the code at IS 875 part 2016. You can see that. If you want a separate video, I'll also make that. So how did you find this video? Keep learning. Drop a like and drop a comment on how much further you have done, or what are your doubts. I'll make sure to reach out to you. Thanks for watching. Bye bye.